LAL0, silence. Complete and total silence. Not the kind of quiet you get on a calm day, but the kind that feels almost unnatural. The air is perfectly still. No breeze, no humidity, no pressure changes rippling through the atmosphere. Look up and you'll see nothing but empty sky. Maybe some thin cirrus clouds streaked across the blue, but nothing with any substance. Nothing with any life. This is LAL0, lightning activity level 0, and it represents something most people never think about: the total absence of atmospheric violence. At LAL0, there is no convection happening anywhere near you. The sun might be shining, but it's not heating the ground enough to create rising air. There are no cumulus clouds building, no updrafts forming, no moisture being lifted into unstable layers where ice crystals can collide and create electrical charge. The ingredients for lightning don't just fail to come together at LAL0, they don't even exist. Meteorologists monitoring atmospheric soundings during LAL0 conditions see profiles that are almost boring in their stability. Temperature decreases smoothly with altitude. Dew points remain low throughout the column. There's no CAPE, no convective available potential energy, which is the fuel thunderstorms need to explode upward. The atmosphere is content to just sit there doing absolutely nothing. For most people, LAL0 is invisible. It's just another day. But for those who depend on reading the sky, firefighters in remote wilderness, pilots planning routes, emergency managers coordinating outdoor events, LAL0 is a gift. It's a day when one entire category of danger simply doesn't exist. No lightning means no random ignitions, no unexpected delays, no scrambling for shelter. But here's what makes LAL0 deceptive. It feels permanent. The sky is so calm, so utterly devoid of energy that it's hard to imagine it ever changing. And yet atmospheric conditions are never static. A front could be built 3 states away. The heat of the afternoon sun could be slowly destabilizing air that seems perfectly calm right now. But the moment the atmosphere finds even the smallest pocket of instability, everything changes, because the sky doesn't ease into electricity. It starts by building towers, LAL1. The stillness has broken, not dramatically, not with fanfare, but subtly. If you weren't paying attention, you might not even notice. The sky is still mostly clear, still peaceful, but something fundamental has shifted in the atmosphere. You're now in LAL1, the threshold where the sky stops being completely dormant and starts thinking about what it might become. At LAL1, there are still no thunderstorms, no lightning crackling across the horizon, no thunder rumbling in the distance. But for the first time, there's potential. The air has started moving. Heat from the ground is creating thermals, small columns of rising air that carry moisture upward. And in that rising air, clouds are beginning to form. Not threatening clouds, just building cumulus, puffy white formations that signal the atmosphere is waking up. The key word here is building. These clouds have vertical development. They're not the flat stratus layers that hang lifelessly in the sky. They're growing upward, fed by air that's being lifted from below. Most of them will collapse before they reach any significant height. The updrafts weaken, the moisture dissipates, the clouds flatten and disappear. But the fact that they're forming at all means the atmosphere has ingredients it didn't have at LAL0: heat, moisture, instability. For pilots, LAL1 is the first caution flag. Those innocent-looking clouds mark areas where air is churning, where smooth flight can suddenly become bumpy. For firefighters, LAL1 is a monitoring situation. The clouds themselves pose no threat, but they indicate the atmosphere is becoming active. The building cumulus you're seeing is the atmosphere testing itself. It's lifting air, cooling it, condensing moisture, and learning what it's capable of. Most days, that's as far as it goes. But when the instability deepens, those innocent clouds stop being harmless experiments. They become launching pads for the first lightning bolts. LAL2. The clouds have multiplied. What was a scattered handful an hour ago has spread across portions of the sky, and they're no longer content to just drift. They're towering, pushing upward with visible purpose, stacking into the kind of vertical formations that make meteorologists lean forward at their screens. Welcome to LAL2, where the atmosphere has moved from testing to serious preparation, and the first real possibility of lightning enters the equation. At LAL2, you still might not see a single bolt all day. Thunderstorms aren't guaranteed, but the potential is real and growing. At least one large cumulus cloud must be present, and often you'll see several scattered across the area, their tops pushing toward 20,000 feet or higher. Some of these towers will develop into full thunderstorms. Others will remain just shy of that threshold, producing maybe a brief shower or a single rumble of thunder before falling apart. But here's what separates LAL2 from LAL1. The atmosphere is now organized enough that thunderstorm intensity is possible. The air is unstable enough. The moisture is sufficient. The lifting mechanisms are in place. Wind shear may be present, giving the storm structure. It's like watching someone load a gun. They haven't pulled the trigger yet, but the weapon is ready. For firefighters, especially those working in wildfire-prone regions during dry seasons, LAL2 is when vigilance becomes mandatory. That single towering cumulus on the horizon might look isolated and harmless, but if it produces even one lightning strike, and if that strike hits the right fuel in the right conditions, an entire forest can ignite from a single bolt. Fire lookouts scan the horizons more frequently. Crews check their gear, aircraft are placed on standby. The deception of LAL2 lies in its appearance. The sky still has blue patches. The storms are widely scattered. It doesn't feel like a dangerous weather day, but atmospheric conditions can intensify rapidly. That cumulus tower that looks stable can explode upward in minutes if it encounters a pocket of instability. And when those clouds organize into thunderstorms, the sky stops building potential and starts releasing it. That's when the first lightning strikes begin. LAL3. The sky has committed. Those scattered cumulus towers from LAL2 have evolved, and now thunderstorms are widely scattered across the area, spreading their influence like dark bruises against the afternoon sky. And for the first time, lightning is visible. Not constant yet, not overwhelming, but real. Occasional strikes, averaging 1 to 2 cloud-to-ground bolts per minute, slam into the earth with enough force to remind you that the atmosphere has stopped playing games. This is LAL3, and the electricity has begun. Each strike you're witnessing carries up to 1 billion volts of electricity, traveling at speeds exceeding 200,000 miles per hour. The channel of air around the bolt heats instantly to 50,000 degrees Fahrenheit, 5 times hotter than the surface of the sun, creating the explosive shockwave we hear as thunder. And this is happening once or twice every minute somewhere within your visual range. Because here's what most people don't understand about LAL3. Lightning doesn't respect boundaries. Bolts from the blue, strikes that occur up to 10 miles away from the parent thunderstorm, can hit under partly sunny skies while you're standing there thinking you're safe. You watch the storm in the distance, see the flashes, hear the delayed thunder, and assume you have time. You don't. This is the level where statistics become personal. In the United States, lightning kills an average of 20 people per year and injures hundreds more. And a significant portion of those deaths occur during LAL3 conditions. Why? Because people misjudge the risk. The storm doesn't look that bad, the rain isn't heavy, so they stay on the golf course, they keep fishing, they decide to finish mowing the lawn, and then physics makes the decision for them. For anyone caught outdoors, LAL3 is the threshold where shelter stops being optional. The 30-30 rule applies. If the time between seeing lightning and hearing thunder is 30 seconds or less, the storm is within 6 miles and you need to get inside immediately. Then stay inside for 30 minutes after the last rumble. But many people ignore this because the storm seems manageable. But occasional lightning is just the warm-up. When those scattered cells multiply and the strike rate climbs, the sky transforms into something far more aggressive. LAL4. The gaps have closed. What were once isolated thunderstorms scattered across the sky have multiplied and spread, now covering 10 to 30% of the visible area. The flashes aren't occasional anymore. They're frequent, averaging 2 to 3 cloud-to-ground strikes per minute. And the thunder has become a nearly continuous rumble. You're in LAL4 now, and the atmosphere has shifted from threatening to actively attacking. But here's the dangerous truth about LAL4. Most of the lightning isn't even hitting the ground. The majority of electrical activity is cloud to cloud, invisible rivers of charge arcing between storm cells, lighting up the clouds from within. You see the flashes, brilliant and mesmerizing, but they don't seem threatening because they're not striking the earth. That's a deadly misunderstanding. Every cloud-to-cloud strike is the storm balancing its electrical charge. And when enough charge accumulates, the system has to equalize. That's when the bolt comes down. And at LAL4, with multiple active cells feeding off each other, the ground strikes are powerful, frequent, and completely unpredictable. For wildfire managers, LAL4 is red alert territory. This is the level where lightning complexes can ignite dozens of fires simultaneously across a region. The 2008 California lightning siege saw over 5,000 strikes in 72 hours, sparking more than 800 individual fires. Fire crews couldn't respond fast enough. The sky was essentially carpet bombing the landscape with ignition sources. The psychological trap of LAL4 is that it still feels survivable. The storms are scattered enough that you can see light between the cells. But the human brain is terrible at calculating electrical risk. We see a storm a mile away and think we have time. We don't see the invisible leader stroke forming in the cloud directly above us, branching downward at a third the speed of light, searching for the easiest path to ground. By the time you see the flash, the lightning has already struck. The visible bolt you witness is actually the return stroke, electricity racing back up the channel from ground to cloud. But at least you can track these storms and escape. The real nightmare begins when the lightning keeps coming, but the rain doesn't. LAL5. The world has gone dark in the middle of the day. The sky isn't just cloudy anymore, it's oppressive. A churning black mass that seems to press down on the earth itself. And then the lightning begins. Not occasional, not frequent. Relentless, violent. Exceeding 3 cloud-to-ground strikes per minute in a barrage so intense that the landscape flickers like a broken strobe light. You've entered LAL5, the highest standard lightning activity level, and the atmosphere is unleashing everything it has. In the most intense storms, you can witness multiple bolts per second. Cloud to cloud, in cloud, cloud to ground. All types of lightning firing simultaneously in chaotic displays that look less like weather and more like artillery. The thunder doesn't come in discrete claps anymore. It becomes a continuous roar, a deep rumbling that you feel in your chest, shaking windows and setting off car alarms blocks away. And then comes the rain. Moderate to heavy precipitation is characteristic of LAL5, often arriving in sheets so thick you can't see more than a few feet ahead. The sequence is terrifying. First the deluge, reducing visibility to near zero. Then the lightning, turning the world into flickering snapshots. Then more rain, washing away any sense of orientation or safety. What makes LL5 truly deadly is that the lightning is persistent. The storm doesn't pulse and fade, it locks onto an area and hammers it for extended periods, sometimes hours. The electrical activity is so intense it creates its own feedback loop. The lightning heats the air, which creates more instability, which produces more lightning. Meteorologists tracking these storms see them intensify rather than weaken over time. The danger isn't theoretical. Side flashes can occur when lightning hits a tall object and the current jumps to nearby conductors, including human bodies. Ground current kills people standing dozens of feet away from the actual strike point. As electricity spreads through the earth or across wet surfaces, the 2014 lightning storm in the San Gabriel Mountains of California exemplifies LAL5 fury. Over a single evening, more than 2,000 lightning strikes hammered a relatively small area, igniting multiple fires that merged into a complex burning across tens of thousands of acres. For aircraft, LAL5 conditions are strictly avoided. Commercial pilots reroute around these storms even if it means significant delays, because the risk of lightning strike can damage critical avionics, navigation systems, and control surfaces. But even LAL5 follows predictable rules. The rain falls, the lightning comes with the storm. There's one more level where those rules break entirely. LAL6. The storm above you looks fundamentally wrong. The clouds are high, their base is thousands of feet higher than normal thunderstorms, and rain is falling from them, but it never reaches the ground. You can see it streaking down in gray curtains, evaporating in midair as it hits the dry atmosphere below. This is Virga, and it's the defining signature of LAL6, the dry lightning situation, the rarest, most dangerous lightning scenario nature can produce. LAL6 is the nightmare that keeps wildfire managers awake at night. Here's why. Lightning without rain. At every other LAL level, even when storms ignite fires, the accompanying precipitation often suppresses some of them. Rain wets the fuel. But at LAL6, there is no rain reaching the surface. Every single lightning strike that hits the ground lands on dry fuel with nothing to slow the ignition. The flash rate is lower than LAL5, typically less than 1 to 3 cloud-to-ground strikes per 5-minute period per storm cell. But spread across the massive area these systems cover, that's still hundreds of potential ignition points. Each bolt falls randomly across the landscape, hitting ridges, valleys, forests, grasslands, anywhere the physics of electrical discharge decides is the path of least resistance. The atmospheric setup for LAL6 is specific and sinister. You need thunderstorms developing over very dry air, usually in middle or late summer, when the lower atmosphere has been baked for months. The storms build high because the dry air forces convection upward. The result is scattered towering cumulus with weak, disorganized cells that produce lightning almost randomly, striking across huge swaths of territory with no discernible pattern. What makes this terrifying is the scale. In a LAL5 storm, the lightning is concentrated. You can track the storm cell, but LAL6 storms scatter across hundreds of square miles. A bolt hits a ridge 20 miles to your north, another strikes a valley 15 miles east, another ignites a forest 30 miles south. By the time fire crews realize how many ignitions have occurred, the fires have had hours to establish themselves in remote terrain. The 2008 California lightning siege was primarily a LAL6 event. Dry thunderstorms moved across the state, dropping thousands of lightning strikes with virtually no rain. The result was the worst fire siege in California history at that time, with over 2,000 fires burning simultaneously. Firefighting resources were so overwhelmed that incident commanders had to make brutal triage decisions, choosing which communities to protect and which fires to let burn. For people on the ground, LAL6 creates a bizarre psychological experience. The storms don't look dangerous. There's no torrential rain, no howling wind. Sometimes there isn't even much thunder because the lightning is so far away. You might see a flash on the horizon and hear nothing at all. But each of those silent flashes could be starting a fire that will burn for weeks. And here's the cruelest part. LAL6 often occurs in wilderness areas, far from population centers, in terrain that's already critically dry from months of drought. The fires ignite in places where detection is slow and access is difficult. By the time smoke is spotted, the fire has grown from a smoldering tree to a crown fire racing through the canopy at speeds that make containment impossible. Meteorologists can predict LAL6 conditions days in advance. When the forecast shows dry thunderstorms, fire agencies go into pre-positioning mode, moving crews and equipment closer to likely ignition zones, staging aircraft at forward bases, clearing schedules for extended deployment. Because they know what's coming. They know the sky is about to betray them in the worst possible way. Lightning without rain, fire without warning. LAL6 is nature's perfect trap. The storms look harmless from a distance. The strikes seem isolated and random. But each bolt is a potential catastrophe, and when dozens or hundreds fall across remote wilderness in a single afternoon, the result isn't just fire. It's a siege. Its landscapes burn simultaneously faster than humans can respond. It's the moment when the atmosphere demonstrates that for all our technology, all our prediction models, all our firefighting resources, we're still at the mercy of physics we can't control. And when those conditions align, when the dry air meets the unstable atmosphere, when the clouds build high and the virga streams down and the lightning begins to fall on fuel that hasn't seen rain in months, there's nothing to do but watch the horizon and count the smoke columns rising. Because LAL6 doesn't just ignite fires, it ignites entire regions. And once it starts, all anyone can do is try to survive what comes next.